Okay, so in section 2.6, we're going to be looking at a quick and efficient way to graph several equations. If you know some basic parent functions graphs, as well as the rules associated to our certain type of transformations, you are going to be able to quickly and easily, hopefully, graph a lot of different functions. So first of all, let's talk about what are some basic functions. Sometimes I will also refer to these as parent functions. And some textbooks refer to those as parent functions. Really, you need to know everything that is on this first page. Okay? Number one, with the linear functions, we know those are of the form f of x equals mx plus b. You need to recognize that. Constant functions are a constant value for our function of the form y equals b. Now, let's start it with our identity function. This is the very most basic line. Y equals 1x plus 0 is another way to write that. That is a line that has a slope of 1 and a y-intercept of 0. So rise 1, run 1, rise 1, run 1. Okay? That's how that is drawn. And also, you can look at a chart of x, y ordered pairs. This says the function value at x is going to be the same thing as x. So that's how that will work for those that table of values. So the quadratic function, the graph of, here you see the degree 2 with the x squared. The graph of the quadratic function is a parabola. And again, you need to know these key points that are outlined in the table. You need to know that y equals x squared contains the point -2, 4. -1, 1. Because -1 squared is 1. Our function evaluated at -1 is -1 squared, which is 1. That's where they are getting this value in our table. Okay? 0 squared is 0. 1 squared is 1. 2 squared is 4. So those purple points there are the key points. It might also be helpful for you to know 3, 9, even though it's off this graph paper, and -3, 9, right? That might come in handy as well. All right, so that's our very most basic quadratic function. Y equals x squared, or f of x equals x squared. For our very most basic cubic function, a cube function, to get all the output values for y, we're going to cube these x values. Okay? And so -2 cubed is -8. -1 cubed is -1. Okay, that -2, -8 would be like down here somewhere. It's kind of off of our graph paper, but it does exist. Okay, 0 cubed is 0. 1 to the third power is 1. And 2 to the third power, 2 times 2 times 2 is 8. And so that is why we get this shape here that we do. Now, if that's not obvious to you, you might want to put some more fractions in there, like 1.5, and then get the corresponding y values. But you need to know that that shape is our very basic cubic function. We're going to be working off of that. All right, next we have the square root function. F of x equals square root of x. Again, let's look at a chart of x, y, or x, f of x ordered pairs that will satisfy that equation. Now recall that underneath that square root, we don't want those values to be negative. That is why on our chart for values of x, we start with only values that are defined for our root function. Not a negative, okay? No negatives. And so that's why you see we don't have anything going on the graph over here. It's just blank, okay? Clean that up a little bit. So then when x is 0, the square root of 0 is 0. The square root of 1 is 1. There are also other points in here, okay, like 2. The square root of 2 is about 1.4, blah, 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 1.4 and then some change. So you do see the 2, 1.4 on there, but that's not actually a key point because it's not pretty. I'm just having to be like 2, 1.4-ish. Okay, that's not quite good enough. So these are our key points that are on the table. Okay, we've got the 0, 0, 1, 1, 4, 2, 9, 3, and then 16, 4. That's off our graph paper. So this little swoop shape like this is just going to be the graph of y equals square root of x. Okay? For our cube root function, we're going to take all our values of x and take the cube root of those. Okay? Now remember, for cube root and for also any odd indexed radical with the 3 right there, okay, we can have negative values for x now. Because you know what is the cube root of negative 8? It's what value was cubed to give me negative 8. Well, negative 2 was cubed to give us negative 8. So that's why this ordered pair works out. The cube root of negative 1. Let me see, and that's off my graph, but it would be like over here somewhere. I'm just kind of eyeballing it. Okay? The cube root of negative 1 is negative 1. The cube root of 0 is 0. The cube root of 1 is 1. And the cube root of 8 is 2. Okay, so that's like way off my graph paper. But this little sideways, laying over on its side, swoopy looking shape like this, S shape if you will, is f of x equals the cube root of x. You need to know and memorize that along with the key points as well. Okay, next, absolute value. The rule here is for each x value we pick out, to find the corresponding y value, we will take the absolute value of that. So when x is a negative 2, okay, our function is the absolute value of negative 2, which is positive 2. The absolute value of negative 1 is 1. There's another key point on our graph. The absolute value of 0 is 0. The absolute value of 1 is 1. The absolute value of 2 is 2, and so forth. So let's call those 5 points the key points on the graph of y equals absolute value of x, which is absolute value is a V shape like this. That's pretty easy to remember, right? Okay. Now, for our reciprocal function, that's what this is called. This is our very most basic graph of a rational function. F of x equals 1 over x. Okay? Now, notice that we don't want negatives underneath a radical. That's a situation that we have to avoid. Also, we don't want 0 in the denominator. So notice on our chart here, let me change colors. Notice on our chart here that there's not a 0 value in here for x, because then we would say, well, the corresponding y is 1 divided by 0, and nope, you can't do that. You're not Chuck Norris. Chuck Norris is the only one that can divide by 0. Okay? So that is why when x is equal to 0, we have what we refer to as an asymptote. That is an imaginary line on a graph that the graph approaches but does not cross or touch. Well, we'll see until we get into 3.5. Then in 3.5, when we have a horizontal asymptote or maybe a slant asymptote, it is possible for a graph to kind of go rogue, if you will, and jump across a horizontal, but never a vertical asymptote. So for our reciprocal function, this thing that does 1 over x, that 1 over business tells us we're going to do the reciprocal. So when x is negative 2, the function value is its reciprocal, negative 1 over 2. When x is negative 1, Okay, the reciprocal is 1 over negative 1, which is still just negative 1. When x is a negative 1/2, 1 over negative 1/2 is its reciprocal, negative 2. So we got a couple of key points here so far. The negative 2, negative 1/2, the negative 1, negative 1, and 1/2, negative 2 would be about right here. Okay, so that'll give us this little curve of our graph. And now let's focus on figuring some positive values for x. When x is 1/2, its reciprocal is 2. 1 over 1/2 is 2. Okay, when x is 1, 1's reciprocal is 1. Okay, when x is 2, 2's reciprocal is 1 over 2, or 1/2. So that's how we're going to get these other key points, this other curve. All right? So know that when you have your reciprocal function, I'm going to put the key points on here and then draw the curve coming up here, approaching but not crossing or touching values that are 0 for y either. Think about it. For this fraction to take on a value of 0, the numerator has to be 0, okay? And the numerator here is not 0. The numerator is always 1. So that's why we're not going to get any output values that are equal to 0 either. We can't put in any input values of 0, and we're not going to get any output values of 0, okay? So pause here for just a minute and look over this first page. You have about 2 seconds to memorize all 8 of these graphs, or these ideas anyway, and then we're going to work with those in the next video.